In this video, we are going to see about the next type of video display devices. They are the random scan and raster scan devices. Let us see first of all what do you mean by raster scan and what is the random scan device. In a raster scan system, the electron beam is swept across the screen one row at a time from top to bottom. As the electron beam moves across each row, the beam intensity is turned on and off to create a pattern of illuminated spots. Picture definition is stored in a memory area called the refresh buffer or the frame buffer. And this frame buffer is the memory area holds the set of intensity values for all the screen points. So here the concept of this raster scan display is electron beam is swept across the screen. That means the lines are drawn from top to bottom. So we can just imagine the screen consists of several rows. They are the lines, and the electron beam is swept from top to bottom. That means from the top to bottom, each and every line is scanned. So that is the raster scan. Okay, from top to bottom every line is scanned, and as the electron beam move across each row, naturally the intensity of this particular place where should be on and off is that takes place to create a pattern of illuminated spots. That means suppose you want to draw a diagram, we know that we can draw any diagram by continuously joining the spots. So now every spot which needs to be turned on, that is intensified by the electron beam which move across. And the picture definition is stored in a memory area called the refresh buffer or the flame buffer. So what is the picture definition is, a picture is a collection of lines or curves or points. Okay, so every lines or curves or points have some x and y dimension or z dimension also. The values of x-axis, y-axis that helps to point those pictures on the screen. So that the group of all the points which comprises any picture is called as the picture definition, and that is stored in a memory area called as a refresh buffer or the frame buffer. So the definition is the refresh buffer or frame buffer is a memory area that holds the set of intensity values for all the screen points. That means whichever point has to be illuminated, whichever point has to be switched on, so those points has some intensity value, and that value is stored in an area called refresh frame buffer. Okay, so now the next thing about the diagram is shown over here. So you can see they have the stored intensity values that retrieved from the refresh buffer and painted on the screen one row at a time. Now the picture is shown here. Now the electron beam sends some electron lines, and that is the electron beam, and that is swept across line by line. So you can see from the first picture, the first line is drawn, and then all the lines are illuminated one by one, and it comes down the screen. So as and when the line is swept across from top to bottom, wherever the picture has to be drawn, those spots are illuminated. Those values are got from the refresh buffer, and this is how the image forms on the raster scan displays. And let us see, on a black and white system with 1 bit per pixel, the frame buffer is called as a bitmap. So now it is a color, it is called as a frame buffer. On a black and white system, it is called as a bitmap, and this bitmap is a collection of 1 bit per pixel which comprises the whole picture that has to be drawn. For example, with multiple bits per pixel, the frame buffer is called pixmap. So bitmap is if for a pixel we have a single bit, that is called as a bitmap, and sometimes the pixels, each pixel is mentioned by multiple bits. In that case, the frame buffer is called as pixmap. That's the difference between the bitmap and the pixmap. And the return to the left of the screen after the refreshing each scan line, that is the horizontal retrace. So that means the lines are drawn. You can see in the picture we have the scan line, that is all the lines over here, and here we have horizontal retrace, this is the vertical retrace. What is the horizontal retrace is? That is going by row all the lines. And once the rows are completed, it again goes back in the vertical trace, which is that is from top to bottom or bottom to top. That is the vertical retrace. So when it is retraced, whichever spots are left out to illuminate will be illuminated. So this is the concept of horizontal retrace. And the vertical retrace at the end of each frame displayed in 1/80th or 1/60th of a second. This is the that is the frame per second. In single second, in a second, how many frames has to be displayed? That is the refresh rate in the vertical trace. So that is the 1/80th means in 1 second 80 frames will be displayed, or 1/60th means 60 frame will be displayed on in a single second. So the electron beam returns to the top left corner of the screen and begin to the next frame. So you can see here the scan, again the scan lines are here, horizontal lines are here, and this is the vertical retrace. So first it starts with the scan line, and then horizontally the electron beam is swept across the horizontal lines, that is the row wise. After it is done for one frame buffer, one element of the frame buffer, we know that frame buffer consists of many frame elements. So when one frame is done, the vertical retrace is done. That means it goes up again to draw the next frame. So this is how every next frame is drawn on the screen using the horizontal and the vertical retrace. So this is how the raster scan displays draw the pictures. So the advantages of these raster scans are we can draw real images here, we can create multiple colors in these pictures, and we can also draw the dark scenes can be pictured. And the problems here is there is less resolution, and you know the resolution is the clarity of the picture. Okay, so how many pixels in the picture are highlighted is called resolution. So high resolution pictures are more comfortable to watch, and these raster scan displays have less resolution, and they display pictures line by line. So the pictures are not drawn immediately. That means if you have, for example, if you have a picture of an apple, how the elements are reproduced on the screen is it first draws the top of the apple, then the next part, like that the line by line the picture will be displayed. The picture will not be displayed as a whole, but it will be displayed as line by line, and it is naturally it is more costlier. This is the problem in the raster scan devices. And let us see the random scan displays. What is the random scan display? As the name implies, the random scan monitors draw a picture one line at a time. Vector is also called as a vector display or stroke writing or calligraphic displays. So the random scan have other names, vector display. Why it is vector display is it is drawn one line at a time. So that is the vector is like a one-dimensional array. So it draws one line at a time. Or stroke writing. We draw some pictures stroke by stroke. That is a stroke writing. Or it is called as a calligraphic. That is the way the letters are written. The Arabic letters we have calligraphic have some sharp edge of the text will be there. So that is the as example. That means the random scan display is also referred as calligraphic displays also. Refresh rate depends on the number of lines to be displayed. Here, for example, to complete a picture, how many lines are there? Based upon that, the refresh rate varies. Okay, and then in the picture definition is now stored as a line drawing commands and area of memory referred to as refresh display file. So here, as we know here, everything is done line by line. So what does happen here? This picture definition is now stored as a line drawing command. That means if we keep on drawing the lines, and wherever it has to be highlighted, those points will be lightened. So one fine time, after all the lines are drawn, we can see the full picture. So that is the random scan display, and that memory is called as a refresh display file or the display list. Okay. Let us see the differences between the random scan display and raster scan display. Raster scan display, as it has the picture with a better contrast. whereas the random display cannot produce contrast. Memory doesn't store intensity values of the picture. Here in the raster scan, intensity values are stored, so we are able to draw the contrast picture. But in the case of this random scan, it is not possible to draw the intensity, that is the contrast pictures. And raster has less resolution and random have high resolution, and raster scan display capable of producing curves better, means we can draw realistic pictures in raster scan, like a biological diagram, zoology diagram. So live pictures can be drawn very well in a raster scan display, whereas in the case of random scan display we can draw the line drawings. Examples are like a drawing of a construction, building construction, or a vehicle construction, which is a non-living thing. So all non-living things which has features with the collection of lines, so those can be better drawn with the random scan display, and it consists of the smooth line drawings. In raster scan display, the systems use the realistic images can be drawn, but random scan cannot draw the realistic scenes. And the cost is less in raster scan, and the cost is more in the random scan display, and it is mainly used for point plotting. For example, the TV set is given. In the case of random scan display, line drawing is also known as vector display. Example is the pen plotter. So plotter is one display device where we can draw the big pictures. Okay. So the difference between the random scan display and raster scan display. So that's all about the concept of random scan and raster scan display devices. Hope it is easy to follow, and thanks for watching.